Assalamualaikum to my both panel, Dr. Hazrina and Dr. Rizal. I hope both of you are in good health during this recovery movement control order. I am Afiqah binti Muhammad Amin, want to present my undergraduate project 2 about vegetation health mapping using medium resolution satellite data due air pollution incident at Pasir Gudang. This slide content have introduction, aim and objective, scope of study, methodology, result and discussion, and lastly conclusion. Introduction. Air pollution is a mixture that made up of gases and particles that release into atmosphere in harmful amount, which this air pollution can be classified into two types, a man-made air pollution and natural air pollution. The cause of air pollution is from various types of activity, which mostly involve human activities such as emission from transportation, emission from industries and manufacturing activities, the open burning, and other activities that can lead to air pollution. Not only cause discomfort, disease, or death to humans, air pollution also can harm other living organisms such as food crops or damage the natural environment. On 7 March 2019, chemical air pollution occurred by the illegal disposal of chemical waste into Kim Kim River in Pasir Gudang, Johor, Malaysia. According to a press release report from Department of Environment, the Hazardous Material Unit team found that the source of the smell came from the Kim Kim River area near the bridge construction project linking with Taman Pasir Puteh to Taman Kota Masai. With the occurrence of air pollution happen at Kim Kim River in Pasir Gudang, Johor, the illegal chemical dumping will produce chemical gas that will affect vegetation around the affected area. Polluted air affect vegetation. From the illegal dumping of methane gas into the river, it forms chemical gas and it disperses in the air. When the diffusion of gases in the air occurs, the floating gas molecule in atmosphere can interfere with the penetration of sunlight towards the vegetation. The sunlight electromagnetic radiation energy radiates to the surface of the leaf and irradiates back, which reflects back to the satellite. The vegetation undergo a process named photosynthesis, it is the process in making their own food by harnessing sunlight. The process of photosynthesis are only possible if the plant has enough chlorophyll. Hence, if the plant is lacking in chlorophyll, will cause the greenness of the plant become less and unhealthy. With the issue of methane, gas affect to the leaf and it disrupts the process of photosynthesis. Therefore, this research is to investigate the trend of vegetation health at Pasir Gudang area in between before, during and after the incident extracted using of medium resolution remote sensing data. The remotely sensed data from satellite may able determine on how polluted air affect vegetation, where the higher the resolution of satellite data, the higher degree of accuracy will achieve during calculation. It is determined in the extraction of 4 remote sensing indices that are normalized difference vegetation index, normalized difference water index, sun-adjusted vegetation index, and atmospherically resistant vegetation index using multispectral based on vegetation from visible spectrum and near-infrared spectrum. So that the aim of this study is to investigate the trend of correlation between the vegetation health with the occurrence of air pollution using remote sensing technique, and the objective of this study is to determine the vegetation health over Pasir Gudang using vegetation indices and to analyze the trend of vegetation indices in between, before, during and after air pollution occurrences using vegetation indices. The scope of study in this research is the study area focus at area of Kim Kim River at Pasir Gudang, Johor. This study primarily uses satellite data, which is medium spatial resolution remotely sensed data and provide visible and near-infrared spectrum. Remote sensing indices used in this study to identify correlation between them and to analyze on the correlation index in order to determine vegetation health trend. For the methodology, this is my research flowchart that consists of data acquisition, pre-processing, processing, data analysis, and followed by output. There are 4 phases in the research flowchart. In the data acquisition phase, two remote sensing satellite data is involved which are Landsat at Oli and Sentinel-2, respectively. The two satellite is chosen because of if one of the satellite data is unusable or not in good condition in particular month, then the other satellite data can be used and vice versa. There are four images that will be used to process based on four dates of occurrences. In data pre-processing phase, there are several processes need to be performed that are radiometric correction, geometric correction, image subset, and cloud masking using QGIS and NV software. This is the pre-processed result image, which is before process and after process. In data processing phase, process and extract the vegetation index needed in the study to gain the value greenness of vegetation. The processing are using software NV software. The four vegetation indices need to be extracted comprised of normalized different vegetation index NDVI, normalized different water index NDWI, soil adjustment vegetation index SAVI, and atmospherically resistant vegetation index RV derived from satellite image. Normalized different vegetation index NDVI acquired to identify the correlation between vegetation and the polluted chemical air during the day of occurrence. The algorithm to determine NDVI value are near infrared minus red divided by near infrared plus red. Normalized different water index to identify the correlation with water content in the leaf. The algorithm to determine NDWI value are near infrared minus SWIR divided by near infrared plus SWIR. While for soil adjusted vegetation index SAVI, to identify the correlation with influence of brightness of soil from vegetation indices, the algorithm to determine SAVI value are 1 plus L multiplied by near infrared minus red divided by near infrared plus red plus L. The atmospherically resistant vegetation index (RV) to acquire to reduce the influence of atmosphere from vegetation indices. The algorithm to determine RV value are near infrared minus 2 multiplied red minus blue divided by near infrared plus 2 multiplied by red minus blue. After processing, these all four vegetation indices were derived based on the location 100 randomly selected point in the study area. This 100 point is located at the same location at the four depth of image in four vegetation index image. For the result and discussion, the quantitative analysis and qualitative analysis on vegetation index will be shown. The quantitative analysis are analyzed with statistical analysis that performed using SPSS software to obtain a correlation between these four vegetation indices. The multiple regression are obtained by analysis of variance ANOVA. And the descriptive statistic of four vegetation index to show the trend of four vegetation index NDVI, NDWI, SAVI, and RV in between, before, during, and after air pollution occurrences. As the air pollution at Kim Kim River incident occurred on 7 March 2019, then the date before occurrence are on 5 February 2019, during occurrence are in between 12 March and 16 April 2019, and lastly, after the occurrences, the date are on 27 May 2019. And here, this is the result of normalized different vegetation index NDVI values calculated using Sentinel-2 image in 5 February 2019, 12 March, 16 April 2019, and 27 May 2019 using Landsat at based on algorithm stated previously. The NDVI range are from -1 to +1. The lower value indicates water bodies and the higher value indicates higher greenness of vegetation. As shown in the figure here, the trend line of correlation between NDVI and four deaths on before, during, and after occurrence of air pollution in 2019. The date before occurrence are on 5 February 2019 are show the result of average 0.583 during the occurrence on 12 March 2019 show that NDVI value slightly declined with average 0.464 and the line is stable until 16 April 2019, a little increase with 0.467 and continue to increase to 0.664 average on 27 May 2019, which are after the occurrences. The NDVI value dropped during the occurrences show that the vegetation health or greenness are affected with the air pollution as the NDVI value range is from -1 to +1, where +1 indicates high NDVI value. Below also show the table of descriptive statistics between 4 NDVI. This is the result of normalized different water index (NDWI) values calculated using Sentinel-2 image in 5 February 2019, 12 March 2019, 16 April 2019, and 27 May 2019 using Landsat 8 based on algorithm stated previously. The NDWI range are from -1 to +1. The lower value indicates cloud or urban area, and the higher value indicates higher water content in vegetation. As shown in this figure, the trend line of correlated between normalized different water index (NDWI) and for date on before, during, and after occurrence of air pollution in 2019. The date before occurrence are on 5 February 2019 are show the result of average 0.269. During the occurrence on 12 March 2019 show that NDWI value slightly declined with average 0.206 and the appearance of the line increased at 0.233 on 16 April 2019. After the occurrences, the trend line continued to increase to 0.359 average on 27 May 2019. The NDWI value is indicate the water content in the vegetation drop during the occurrence, show that the water content in the vegetation are also affected with the effect of air pollution, as the NDWI value range is from -1 to +1, where +1 indicate high NDWI value, and below is show the table of descriptive statistics between 4 NDWI. And this is the result of soil adjusted vegetation index (SAVI) values calculated using Sentinel-2 and Landsat 8 based on algorithm stated previously. The SAVI range are from -1 to +1. The lower value indicates water bodies and the higher value indicates higher soil brightness of vegetation. As shown in this figure, the trend line of correlation between soil adjusted vegetation index (SAVI) and for date on before, during, and after occurrence of air pollution in 2019. The date before occurrence are on 5 February 2019 are show the result of average 0.338, where the trend line are decreased to the during of the occurrence on 12 March 2019 with average SAVI value is 0.294 and it is continued to fall with 0.283 until 16 April 2019. After the occurrences, the trend line continued to increase to 0.435 average on 27 May 2019. The SAVI value is identified the correlation with influence of brightness of soil from vegetation indices. The soil brightness show low value during the occurrences in between 12 March and 16 April 2019. It indicates that the soil brightness of vegetation are affected by the effect of air pollution, as the SAVI value range from -1 to +1, where +1 indicates high value of SAVI. Below is also shown the table of descriptive statistics between 4 SAVI. This is the result atmospherically resistant vegetation index (RV) values calculated using Sentinel-2 image in 5 February 2019, 12 March, 16 April 2019, and 27 May 2019 using Landsat 8 based on algorithm stated previously. The RV range are from -1 to 1. The lower value indicates water bodies and the higher values indicate higher influence of atmospheric factor from vegetation. As in this figure show the trend line of correlation between atmospherically resistant vegetation index and for that on before, during and after occurrence of air pollution in 2019. The date before occurrence are on 5 February 2019 are show the result of average negative 0.006. During the occurrence on 12 March 2019 show that RV value sharply declined with average negative 0.011 and the line is stable until 16 April 2019 with negative 0.011. After the occurrences, the trend line started to increase steadily to 0.0013 average on 27 May 2019 occurrences. The RV value dropped during the occurrence showed that the RV value to reduce the influence of atmospheric factors from vegetation are affected with the air pollution as the RV value range is from -1 to +1, where +1 indicates high RV value and below is shown the table of descriptive statistics between 4 RV. In quantitative analysis, the two correlation analysis been carried out using t-test and multiple regression. The correlation analysis to see the strength of the relationship between the parameters. The parameters are NDVI versus NDWI, SAVI, and RV. The t-test on 5 February 2019 show the p-value is 0.000 is less than 0.05 between NDVI versus NDWI, SAVI, and RV. It proved to reject the null hypothesis and H1 is accepted where there is sufficient evidence to conclude that the correlation is not equal to 0 and it is highly significant. It is shown that there is a significant linear relationship between NDVI and NDWI as the population correlation coefficient are 0.567, NDVI and SAVI as the population correlation is 0.888, and between NDVI and RV is 0.873. All the results show a positive correlation as shown in the figure. The t-test on 12 March 2019, the p-value also showed less than 0.05 between NDVI versus NDWI, SAVI, and RV. It proved to reject the null hypothesis and hypothesis 1 is accepted, where there is sufficient evidence to conclude that the correlation is not equal to 0 and it is highly significant. It is shown that there is a significant linear relationship between NDVI and NDWI as the population correlation coefficient R is 0.807, NDVI and SAVI is 0.779, and between NDVI and RV, the population correlation coefficient is 0.936, and all the results show a positive correlation as shown in the figure here. In the t-test on 16 April 2019 also show the p-value is less than 0.05 and it proved to reject the null hypothesis. It is shown that there is a significant linear relationship between NDVI and NDWI as the population correlation coefficient R is 0.592, NDVI and SAVI is 0.899, and between NDVI and RV as the population correlation coefficient is 0.663, and all the results show a positive. T-test on 27 May 2019 show that there is a significant linear relationship between NDVI and NDWI as the population correlation coefficient R is 0.707, NDVI and SAVI 0.897, and NDVI and RV is show R value is 0.860, and the results show a positive correlation that obviously show that p-value is less than 0.05 and it proved to reject the null hypothesis and the correlation is not equal to 0. It is highly significant correlation. The multiple regression NDVI versus NDWI versus SAVI versus RV on 5 February 2019 show that the p-value 0.169 is greater than 0.05. Hash O is accepted and it can be concluded that the mean value of 4 different vegetation index groups are the same, while multiple regression on NDVI versus NDWI versus RV versus RV on 12 March show that the p-value is 0.000 is less than 0.05 and HO is rejected, and it can be concluded that the mean value of 4 different vegetation index groups might be different. And the multiple regression on 16 April 2019, where NDVI versus NDWI versus RV versus RV show the p-value is 0.000 is less than 0.05, where HO is rejected, and it can be concluded that the mean value of 4 different vegetation index groups might be different. And for 27 May 2019, the p-value 0.031 is less than 0.05. HO is rejected, and it can be concluded that the mean value of 4 different vegetation index groups might be different. The result of correlation analysis vegetation index on 5 February 2019. The statistical analysis result as figures show that the correlation of determination analysis R2 give the significant test result for the 3 pair of vegetation index respectively. The R-square result show the positive linear association to the 3 pairs of vegetation index 1, 2, and 3 components. The statistical analysis above show that NDVI is correlate with SAVI and RV higher than NDWI. Furthermore, the p-value 0.000 show that NDVI is highly significant to NDWI, SAVI, and RV. Therefore, it is shown that each parameter has strong correlation, and it is strongly relevant to produce trend model of vegetation health effect by air pollution in this study by using remote sensing technique. On 12 March 2019, the statistical analysis results show the correlation of determination analysis R2 give the significant test result for the 3 pair of vegetation index respectively. The statistical analysis show that NDVI is correlated well with NDWI, SAVI, and RV. The p-value 0.000 show that NDVI is highly significant to NDWI, SAVI, and RV. Therefore, it is shown that each parameter has strong correlation, and it is strongly relevant to produce trend model of vegetation health effect by air pollution. The result of correlation analysis on 16 April 2019. The R2 give the significant test result show the positive linear association to the 3 pair of vegetation index. However, pair 1 and pair 3 indicate small positive linear association with result 0.350 and 0.439 compared to pair 2, which indicates large positive linear association with result 0.809. As summary, the statistical analysis above show that NDVI is correlate with SAVI higher than NDWI and RV. Furthermore, the p-value 0.000 show that NDVI is highly significant to NDWI, SAVI, and RV. Therefore, it is shown that each parameter has strong correlation, and it is strongly relevant to produce trend model of vegetation health effect by air pollution in this study. Lastly, for the vegetation index on 27 May 2019, show pair 1 indicates small positive linear association with result 0.499 compared to pair 2 and 3, which indicate large positive linear association with result 0.805 and 0.739. Furthermore, the statistical analysis above show that NDWI is correlate with SAVI and RV higher than NDWI. The p-value 0.000 show that NDWI is highly significant to NDWI, SAVI, and RV. Therefore, it is shown that each parameter has strong correlation, and it is strongly relevant to produce trend model also. For the qualitative analysis, according to previous study, transboundary air pollution and its effect on vegetation by Ria Buhina Maisky, the general analysis using the example of the Orenburg region to analyze the characteristic of transboundary air pollution and impact on vegetation cover based on the result of regional study of aerotechnogenic environmental pollution. It shows the dynamic of emission of pollutant into the air from stationary sources. As shown in the figure, the gas industry and chemical and petrochemical are on the list that place at 8th and 10th place in terms of emission of pollutant into the air. Ria Buhina Maisky et al. 2019 stated that the object from the gas industry emit a sufficiently large amount of nitrogen oxide where the lifetime of the pollutant reaches several days in the atmosphere. They also has stated that the effect of the solid component of dust and gas emission will lead to a decrease of the vital state of the woody plant, which will manifest in relation of the content of metabolism such as sedimentation of calcium salt in the wood, premature aging, morphological changes, slower growth, and development towards the vegetation. For the conclusion, vegetation health is important to the vegetation as it plays an important role to the environment where the vegetation becomes atmospheric purification and air pollutant reduction. According to Florentina and I.O. 2011, the vegetation has made exchange with part of the atmospheric gases through photosynthesis, respiration processes, and the final stage of litter decomposition, which are the mineralization. Hence, the health of this vegetation may contribute well to the climate change. Remote sensing technique has been used to extract the vegetation index that comprise of NDVI, NDWI, SAVI, and RV that derive from satellite image Sentinel-2 and Landsat-8. The values of vegetation index can simply generate by using vegetation index formula in order to determine the correlation between vegetation indexes. The quantitative analysis needed in this study. After that, the relationship of the data used can be identified. This vegetation index generated to analyze and to gain the greenness value of the vegetation. Therefore, the result of the vegetation index analysis have clearly shown that the value of vegetation index has been affected by the air pollution that occurring at Kim Kim River incident. That's all. Thank you so much for listening and watching to this presentation.